Welcome you all for Department of Collegiate and Technical Education. This video session is a continuation of video session number 3 Engineering Mechanics and Strength of Material for 3rd semester for Civil Engineering Department. This is also a continuation of the Introduction to Engineering Mechanics Unit 1. Let's move to next slide. Table of content. These are the following topics which will be covered in this video. First, recap of the first session 3. Recap of session 3. Resultant force, moment, Varignon's theorem or law of moments, couple and numerical problems, multiple choice question. First, recap. In previous video session, we have covered the sign conventions of forces and resolving of forces and resolving the forces in different orders and some simple examples. Before watching this video, I suggest please watch the video session number 3. Let's continue this in this video session. Let us repeat once again the sign convention of forces, what we have done in video session number 3. Here in quadrant 3, in quadrant 1, forces will be split in two directions, perpendicular forces. One is vertical and one is horizontal. Here vertical will be positive because x-axis is here positive, and horizontal is also a positive because here horizontal also positive in first quadrant. In case in second quadrant, force will be in this direction and the horizontal component and vertical component will be in this direction. Vertical component, horizontal component. Vertical component is positive because it is positive here and positive here, and horizontal component is negative. And third quadrant, force will be in this direction, F will be in this direction, here F will be in this direction, force will be in this direction. To resolve it into two perpendicular components, one is horizontal and another one is vertical. The horizontal is negative here because it is moving in this direction, here negative, and other one is positive. Sorry, other one also is negative. Then fourth quadrant, the horizontal component and vertical component are like this, force H and B. Here horizontal component is positive because it is moving in right side direction, vertical component is downward direction, so negative. Here it is negative. Then this is it all. In first quadrant, whichever the force component force, horizontal vertical component force in upward direction is positive, and which the horizontal force which is in right side direction is positive. Both are positive. And in case of second quadrant, the vertical component will be positive and horizontal component will be negative. In third quadrant, horizontal component will be negative and vertical component will be also be negative. And fourth quadrant, vertical component will be negative downward direction and horizontal component will be positive, which is moving in right side direction. Same way, in first quadrant both are positive. Second quadrant, vertical component positive, horizontal component negative. Third quadrant both are negative. Fourth quadrant, vertical component negative, horizontal component positive. Let's move on to the next slide. This was done in previous slides, previous session also. I will repeat this slide because to understand, for better understanding of the in this session. Resultant force. The resultant force What is resultant force? Combined effect of all number of forces which produce the same effect as a resultant force. It is a combination of many forces. Resultant force is a combination of many forces. Here, let us study by a graphical representation. The block where force is applied. Two forces are applied. One is 500 Newton, and other one is Q 250 Newton. The force is applied in the direction in direction to east or right side direction. Both forces are in the right side direction, and they are like parallel forces. We can call it like parallel forces. Then total forces will be resultant force will be R equals to P plus Q, that is 500 Newton. P is 500 Newton plus 250 Newton equals to 750 Newton. When both forces are at a same direction, forces are in same direction, then it should be added. The force should both the force should be added so that you to get the resultant. And resultant is 750, and it will also be in the direction both the P and Q are in same direction. Both the P and Q are in same direction, which was P was in this direction and Q was in this direction. This resultant force will be also in this direction only. Some we came to know that the sum of two parallel forces which was acting on the block was in the same direction. The resultant will be P plus Q. P plus Q is equal to resultant. And to know the direction, in which direction the block is moving, or what is the resultant of direction of the resultant, then this is the resultant, because both the forces are having same direction, so resultant will also be in same direction. Next, here the second type of problem, P is equal to 500 Newton, where it is acting in right towards the right side of the toward it is acting to left side, but it tend to move the block towards right side. And other one is Q, which is acting at a left side direction, which acting in moving in the direction of left side. P is 50 Newton, and Q is 250 Newton. Here the direction of the P, where it in we know in sign convention, the horizontal force which is in this direction will be positive, and for horizontal force in left side direction is negative. Now with this force, P force is in the direction of right side. That's what P is equal to 5 plus 500 Newton. Resultant force is equal to P plus Q actually, but in this case it will be changed in P plus P sum of all forces. We can write resultant is equal to sum of F1 plus F2 plus F3. If there are number of many forces, there is more than one or two forces, and then it should be summation. The summation in the sense it can be written as summation of all forces, all horizontal forces. We can add it in like this. It should be all or should be horizontal. It can be written also like this. Resultant is equal to F horizontal 1 plus F horizontal 2. Here all are horizontal forces. Same way, if you have to find out the resultant of vertical forces, our resultant is equal to force F V H1 plus V H2. But in the case, what we will do is in our video session or all our slides, we have taken as H as the horizontal component, vertical as the vertical component, V as the vertical component, H as the horizontal component, V as the vertical component. We will write this as H1 plus H2 plus H3. It depends upon oneself that they can decide what notation we can use. I'll erase all. I'll write once again. P is equal to 500, where a resultant force, when it is in resultant force, to find out the resultant force, R is equal to 500 Newton, which is in this direction, and Q is in opposite direction, that was minus 250 Newton. The answer will be 250 Newton. Which direction? Force will be in which direction? Resultant force will be in which direction? Uh, whichever the force has more magnitude and more magnitude, then that direction will be the of force. Here 250 Newton, the 500 Newton is in right side direction, 250 Newton will be in this direction only. Direction will be okay. We came to know that from both slides. Let us see. Yes, P and Q are okay. Resultant is 250 Newton. Resultant force is 250 Newton. Resultant force is 250 Newton. Now, when forces on same direction, when two forces in same direction, P and Q in same direction, then resultant force will be P plus Q. When two forces are different direction, P is in this direction and Q is in opposite direction, then resultant force will be P minus Q. The force force which has the force which has the larger the force which has higher magnitude will take the direction of the force. Next, here the two football players are kicking the ball. One of the player is kicking the ball with a 75 Newton. Assume it as 75 Newton. He is the 70 Newton of the force is kicking the ball, and same way other person is kicking the ball with a 125 Newton force. 125 Newton force. Here the force is in opposite direction. We all know that force is in opposite direction. It is 75 Newton, and other force is in one force is 75 Newton, which is other force which is 125 Newton. I'll write in free body diagram. This is called free body diagram. Spaced bar diagram will be converted into free body diagram. 75 Newton. Now the direction of the force are opposite, so the resultant force will be 75 Newton minus 125 Newton, because it is in left side. 75 is positive because it is in right side direction, and it's in left side direction, so that's why it is negative. Then is equal to minus 50 Newton. Answer will be minus 50 direction. See, in answer only it is written minus 50 degree. Minus 50 degree in the sense which is the direction of the force will be, or the direction of the resultant will be in towards the left side. The ball here moves in the left side direction after both of them kicking the ball simultaneously with 75 Newton and 125 Newton. Here this person has a higher magnitude of force. This higher magnitude of force, and the ball moves in the direction of the higher magnitude force. I hope you understood the how to calculate the simple resultant force in a collinear force or parallel forces, which is in same direction opposite direction. Let's move on to next slide. What is the resultant force? Okay, another illustration problem with a graphical representation. Here in this problem, here the person here is pushing the table or a piano or a table. Let us call it as table. Person is pushing the table with 100 Newton force, 100 Newton force, and same way in other person also pulling the table with 150 Newton force. The free body diagram will be 100 Newton and 152 Newton, which is collinear force, and resultant force will be 250, as it is sum of all two forces. Here, resultant will be P plus Q, as it is in the same direction. P plus Q. P plus Q is equal to 100 plus 150, that is 250 Newton. 250 Newton. Next, same illustration problem. Person over here is pushing the table in 100 Newton, and the person is over here is pulling the table with 150 Newton. In case of above, both the direction of the force was towards the right side. Now the force of this person pushing the table is in this direction, and the other person pushing the table is in this direction. The opposite side of forces. The free body diagram will be 100 Newton in left side direction and 150 Newton in other side direction. There were resultant force will be P minus Q, that is P is equal to 100 Newton minus 150 Newton equals to minus 50 Newton. Minus 50 Newton, minus indicates the force is in the direction of, oh, okay, this is mistake. Minus P is in minus direction, this is in the opposite direction, minus direction, and for 150 is in positive direction. It is on the right side, this direction is on the left side. Whichever body, the force moves in left side is minus, force which is in moves on the right side is positive 150 Newton. That's why it's minus 50, minus, it will be minus or plus positive only, positive 50 Newton, because minus 100 plus 50 is equal to plus 50 Newton. In this, for positive indicates that the direction of the force, resultant force will be in this direction. As a resultant is 50 Newton. Next slide. Method of finding the resultant force. The following methods can be used to find the resultant force. First one is parallelogram law of forces. In parallelogram law of forces, there are three methods: parallelogram law of forces, triangular law of forces, and polygon law of forces. Let us discuss one by one. We will discuss only parallelogram or triangular law of forces. Okay, parallelogram law of forces, where two forces, namely P and Q, two forces P and Q will be the sides of the two parallelogram. Then the resultant force will be the diagonal of the parallelogram. I repeat, if P and Q are the two forces which is indicated as two sides of the parallelogram, then its resultant force will be diagonal of the parallelogram. The resultant force will be calculated as P square plus Q square, R square, resultant square is equal to P square plus Q square, where this is theta, plus 2 cos theta P Q. This is the formula to find the resultant force. And in case of triangular law of forces, we have already discussed the triangular law of forces in resolving the forces. While resolving forces, I will repeat once again. Next is triangular law of forces, where two forces, when force is resolved, when force is resolved, horizontal and vertical component by what horizontal and vertical component, this force can be replaced in a triangle in such a way that the force, horizontal force in this direction H, and vertical force in the form of right angle triangle, vertical force in upward direction, then resultant will be the hypotenuse of this right angle triangle. Resultant will be the resultant the hypotenuse of where theta is the direction of resultant force. Here resultant can be calculated by r square is equal to h square plus v square, a simple Pythagoras theorem. Here we are using simple Pythagoras theorem. And polygon law of forces. In polygon law of forces, next one is polygon law of forces. In polygon law of forces, the force, when two or more force acting on this these are concurrent forces. These are concurrent forces. Example of concurrent forces. When force F1, F2, F3 is F4 is acting concurrent. It's a concurrent forces. Then the polygon, it can be represented as F1 as the sides of the polygon, F2 F1, F2, F3, F4, and the total force and resultant force, which will be the resultant force. This can be in the form of, this can be represented in the form of polygons, a closed traversing, like kind of closed traversing. It can be represented in a polygon. Next, we will move to the next slide. Law of transmissibility of the force, where when the body is in rest, when the force is applied on a body, and the force moves in the body moves in the direction of the force, where which is subjected to the force, body which is subject to the force. The point of application of force will be along the line of application of the force. The movement of the force or point of application is along the line of application of force. The law of transmissibility of forces is a state of rest of uniform or of a rigid body is unaltered if the point of application of the force is transmitted to any point of application of the force along the line of application of the force. It means that I will explain it once again. If the force is, let us assume the force, a body, this is a body, and if we apply the force in this direction, and this is the line of application of the force, if we apply the force, it will have the same effect if we apply the force here also. If we apply the force at here also, let us name it A, B, C, D, E, F. When we apply the force of 10 kilonewton, in at A, will produce same effect if we apply the 10 kilonewton at B also. Even in the case of C also, or D also, because it is lying on same line of action of force. Line of application of force is same. All the points A, B, C, D is in collinear and it is in the same line of application. Then the force applied in all this line of application will be has same effect altogether. Whenever it is applied in A or B or C or D, all will be having same effect. Here in this the body where force is applied at A, and in this the line of point of application is A here, The line of application is AB, line of application of the AB. The state of rest of uniform the motion of the body is unaltered if the point of application is A or B or any other point in this any intermediate points between A and B. Here, with the example where pull body a point of application of the point is in the here, but in the case of push, the point of application of the force is back side of the door. In here, it is in the handle. Pull is in the handle. It is in the back side of the door. It has it is in the same line of action. It is in the same, both force are in the same line of action. It will produce the same effect. The motion, it will produce the same uniform motion of the rigid body. Let F be the force acting on the rigid body at a point A. Yeah. And according to the law of transferability of the force, this force has same effect on the state of the body as the force applied at a point B also. Even not only B, between A and B, wherever the point, in any point the force is applied, the magnitude of force applied F is F, and it is applied in any point between A and B, the effect of the force will be same. As in same case here also. Next is moment. Moment, it's a product of force into perpendicular distance. It's a product of force into perpendicular distance. When moment is applied on the body, when moment is applied on the body, or force is applied on the body, when the body rotates, let us assume this part of the this is the body with a rigid, it is fixed here and it is rigid here. When the force is applied on the body it has a tendency to rotate the rotational effect on the body. It will make a force which makes the rotation. This force which makes the rotational effect on the body is called moment, which will be in the particular distance. It will be in certain distance d. It is mathematically also defined as moment equals to force into perpendicular distance. Force into perpendicular distance, that is d. F into d. Moment is equal to F into d. Let us understand by illustration now. Here, the moment of the force is defined as product of force and perpendicular distance of the force from the axis of point of rotation. From where the distance, from the distance or the rotational effect of the rotational effect distance of rotational effect, or the point of distance from the force to the point of rotation. This is the point of rotation here. This is force applied. The L distance between the point of rotation and force is called point of rotation. This is d. Then moment will be the product of force and distance. That's L here. We call it d. Suppose in this figure, the moment is also known as it's the rotational effect of force on the body. It's also called as rotational effect, which causes rotational effect of the force on the body. Here F is a force where A is a body which is fixed here, where A will be the point of rotation. It will be the point of rotation. When force is applied on this AB member here at point B, there is the distance from point of rotation to the force is d. Distance between the point of rotation and the point of application of load is d, which is also a perpendicular distance. It will be always be the perpendicular distance when force is applied. D will be the perpendicular distance to the F. Here moment will be is equal to the moment will be generated at the rotation. It will be generated here. Point of rotation will be here. It will be generated in a point A. The moment will be generated. The moment will be it will rotate the body, rotate this AB member in clockwise direction. We will rotate the moment in clockwise direction. This moment is, we denote it as MA. What is MA? Where M is a moment and A is the point of rotation. That's why we call MA. Moment at the point A. We also refer it as moment at the point A. Moment, M is a moment and A is the point of rotation. Moment A, MA will be equals to, mathematically, it's a product of force and perpendicular distance of the force. It's a product of force F, perpendicular distance is D. Perpendicular distance is D. Okay, let us know now with a small numerical example. I'll name the value F is equal to 10 kilonewton, and D is equal to 2 meter. What will be the moment of the, what will be the moment at A? The moment at A will be equals to, force into perpendicular distance. Force into perpendicular distance. Moment at A, force is 10 kilonewton and perpendicular distance is 2 meter, and it will be 20 kilonewton meter. The unit of force is Newton, and unit of length perpendicular distance is meter. Then the unit of moment will be, it's a product of force and distance, then Newton meter, or Newton of force will always it will be represented in kilonewton, or it can be called as kilonewton meter, or if the length will be represented in millimeter, it will be represented as Newton millimeter also. Force MA. For the force F shown in the figure, the moment about point A, where A is the point of rotation, is MA will be MA, moment about A, is also called moment about A, equals to force into distance. What is distance? This distance is perpendicular distance. Moment equals to force into perpendicular distance, where the moment is, there is rotation of MA, moment will be in this direction. Moment will be in this direction. This makes the member AB to rotate in clockwise direction. Suppose clockwise direction. Okay. The example for the moment where moment is applied is, we regularly use moment where when we open the gate or when we open the door while rotating the screw with the help of spanner. Here the screw is rotated with the help of spanner. We apply the force in certain distance here, with the L distance, as they are shown in the graphical representation figure, where force is applied. F force is applied here, and moment is point of rotation. Moment will be generated here. Due to if there is a restriction, the moment will be generated. And if there is no restriction, there will be moment. The movement it will be there. So that's why the moment will be in this direction. Moment will be in this direction. The product is MA, moment about point MA equals to this. Consider this as A, and moment about A is equal to, this is not, this is other figure. This force is F actually. It's not. It has been overlapped. F. Okay. MA equals to F into L, where distance, perpendicular distance is denoted as L here. F into L. In case of the door, this will be the distance force applied will be here. We'll open while opening the door or pushing the door or pulling the door. We'll apply the force here, and the moment will be generated here, where we can easily open the door. The moment you can try this. When we try to open the door with a close to the hinge, it is difficult to open. It is difficult to open. When there is certain distance, like at the end of the door sleeve, if we try to open here from here, it will be opened very easy. The moment will be larger. Moment is directly proportional to the distance. Moment will be The rotation will be easier. The rotational effect will be easier, or rotational effect will be easier when the distance is larger. The rotational effect will be difficult when distance is small. Rotation will be easier when distance is large, and difficult when distance is moment. If you want to increase the moment, then we have to increase the distance in the sense distance between point of rotation and application of force. Distance between the point of application and distance between the force. We have to increase this distance. Hope you are thorough with the concept. Next, law of moments. It is also called as Varignon's theorem. What is law of moments? In law of moments, the algebraic sum of the moments due to all forces acting on a body about any point is equal to the moment of the resultant about the same point. What does it mean? It means the force which is on when the forces are a number of forces acting on a body. Number of forces here. Let us consider the force is acting on a body. F1 force, F2 force, and F3 force, and F4 force is acting on a body. Suppose if force is acting on a body, it will create a resultant. How should we calculate resultant? The sum of adding all resultant is calculated, or sigma v. Or resultant is also called sigma v. The sum of all vertical forces, F1 plus F2 plus F3 plus F4. All the forces are, the resultant force will be in somewhere in direction is somewhere between A to B. It will be, resultant force will be acting A to B, resultant force. What does this law of moment say? If we take the moment from A, moment about A, the moment of all these forces, sum of moment of all these forces, F1, F2, and F3, all these forces, the moment of all these forces will be equal to the resultant, the moment of resultant. I will explain once again. Moment resultant into x distance with respect to it will depends upon the distance between R and A. Then let us call it x, and F1 into A, sum of moments, moment of this force. Next, moment of this force, let distance be A, B, and C and D, plus F1, F2 into B, plus F3 into C, plus F4 into D, where A, B, C is the distance, each force distance from A to F1, A to F2, A to F3, and A to F4. Law of moment says the moment of all forces, sum of moment of all forces The algebraic sum of moment of all forces acting on a body about any point is equal to the moment of their resultant. Is equal to the moment of their resultant. Sum of all moments m is equal to m1 plus m2 plus m3 moment sigma m, or sum of moment m1 is f1 into d, m2 is f2 into d, f3 into d, or we can write this as the law of moments or Varignon's theorem as in the form of like this: uh, moment or moment of r into distance, moment of resultant, that is m resultant, moment of resultant will be equals to summation of all moments. This is summation of moments. All the force m1 is f1 into distance, f2 into distance, f3 into distance, like summation of m1 plus m2 plus m3, so on. Here the moment is calculated as f1 into a, and a is the distance. When point is moment is taken a moment about a, the moment about a is where moment is taken from a. Let us consider this as, assume it as rigid, and the moment is considered from the point a, and f1 into ab, and plus f2 into ac, minus, I have taken here the clockwise as negative and anti-clockwise as positive, minus f1 into ab, where force into perpendicular. So force we are taking first is force f1, which is distance into ab, and second force f2, distance here will be ac, distance from here to here. Whichever force we are selecting, it should be distance from the axis of rotation. The rotation, it should be from the rotation axis where the moment is we are calculating. And next f3 is a into d, f3 a into d, and f4 is, this will be resolved here again. Force will be resolved here. The force is in this direction. It will be resolved into two for two direction. It will be resolved in this two direction, and this force will be taken, and the vertical component will be f4 sin theta. It should be sin theta, sorry, here it should be sin theta, sin theta, f4 sin theta, which is at a distance of AE. Force is f4 sin theta. Other force is what, horizontal force, which can take, because we are taking the force which is here, it will move in this direction only. Force horizontal component will move in the point of application. There is no perpendicular distance to this. There will be no perpendicular distance. As in case of F5 is not taken here, but F5 will be F5 into zero distance. That's why F5 is neglected here, because F5 is moves in the direction of the point of where we are taking the moment of at the point. It is collinear, and there is no perpendicular distance here. If we consider the f1, there is perpendicular distance, because f1 it will pass on the point of rotation. When the force passes in the point of rotation, there will be no perpendicular distance. There will be perpendicular distance will be zero. That's why zero multiplied by anything force will be zero. That's why we neglect such forces which passes through the point of rotation. Here H horizontal component of this force and F5 force passes to the axis of rotation. That's why both forces are neglected. Here we came to know that how to calculate the moment of all forces. Now let us consider the resultant of forces. Resultant of forces, I'll assume somewhere here, resultant is somewhere here. It is the effect of all the forces combined together, that is resultant of forces, which is at a distance of a. Sorry, it is a distance of x. Let us consider it at a distance of x. Now, the law of moments or Varignon's theorem states that the resultant moment of resultant about a, which is r into x, moment of resultant about A, moment of resultant about A, moment about A, moment about A result R into X will be equals to this sigma MA what we have written here. Sigma MA, sigma MA, the sum of all moments of all forces will be equal to the resultant of moment of resultant, equal to the moment of resultant. That is Barignan theorem. Next couple. Couple, when two forces act of same magnitude with in opposite direction, it will same magnitude in opposite direction. It forms a two moment forms a couple. Suppose when in the point force is acting, a moment is acting, two moments acting MA, let us consider MA acting at a point, acting in the MA in this direction, and other forces acting in this direction. We consider this axis, it is acting in this direction, MA only. This forms a couple. The couple consists of two forces which have same magnitude acting in opposite direction, that which are not acting along the same straight line and separated by a distance. It can be separated by a distance. One acting in this direction, another acting in this direction. This forms a couple which should be in a certain distance. It should be in a certain distance. Suppose it's acting in this point MA and this point acting at MB in particular distance D, for distance between D, and this forms a couple along with the straight line and separated. The couple produces only rotation without any translation. It has a rotational effect on the body. Here, while in car steering, when we rotate the steering, the force applied here, force will applied on this left hand side will be in this direction, force applied will be in this direction, and force applied on the right hand side will be in this direction, which is at a certain distance D, let us call it as D, which forms a couple here. This forms a couple rotation effect here, and this will form a rotation effect like this. This forms a couple. Same case here while pedaling the cycle, there is a certain distance between two foot. Let us call as D. The one foot is force applied in this direction, which creates a moment on this rotation anti-clockwise. Or here, this force is applied here. Force is applied in this direction, and it creates a moment like it has a distance. Particular there is some distance between these two forces applied, which forms a rotational effect. It is called couple. The couple, it has the same magnitude. It has same magnitude. Here is the force F is equal to F. The force which is same magnitude 10 kilonewton. If we apply force in 10 Newton, here also we apply force in 10 Newton. In the same case here, 10 we apply force 10 Newton. Here also we apply force 10 Newton, which will have same magnitude. Couple will have same magnitude. Force which have same magnitude acting in a opposite direction. This is very important. Acting in a opposite direction, which should have some distance, separated by a distance. Let us understand more clear with the help of graphical representation figure. Look at the steering where it is rotating. While rotating in clockwise, the two couples at a distance at the width of the diameter of the couple, width of the steering will be the distance between the two couples, and the force applied while turning the steering of the car, we apply force in both hands, then it forms a couple. And in case of pedaling the cycle also, there will be force applied in both the pedals. It is at a certain distance we apply the force, where it forms a couple which cause into motion. It causes cycle into motion. The rotational effect produced by the couple is known as moment, moment of the couple. It is the product of magnitude of any force and the perpendicular distance. Same. It is calculated. It is calculated. The each for each it is a combination of two moments. Couple is a combination of two moments. The how we calculate the moment is calculated in same manner. It is calculated separately. Where both the moments are equal. If we calculate one is sufficient. The couple are classified depending upon the sense of rotation of the moments as clockwise and anti-clockwise. There is clockwise couple and anti-clockwise anti-clockwise couple. Depending upon the rotation effect of the moment, it is classified to anti-clockwise moment and anti-clockwise couple. Okay. Here also the couple produces the weight of the force. The push will push of the push he pushes from his left and it creates a couple here due to force, and here due to weight also it creates a couple here which has a certain distance between the two force D. That is the couple is formed. Multiple choice question. Let us study one by one. Two force acting in the same direction east is given by P plus Q, P minus Q, minus P minus Q, all the above. It is moving in the direction of east, that is direction of east. P, two forces are moving in the direction of east. It is positive. Suppose this is P and this is Q. This is positive plus P and plus Q, where resultant will be P plus Q. Here in the option P plus Q is there. This is the answer. Let's see. Yes. Next. The resultant of two forces P and Q acting along the same straight line, but opposite direction is given by when the force is acting on the same straight line P and Q, but acting in opposite direction. Then there is given by the resultant force will be P minus Q, because P is in positive direction and Q is in left side moving left side direction, minus P minus Q. Let's see the option. P plus Q, P minus Q, P by Q, P Q by divided by P, Q by divided by Q, Q divided by P. The answer is P minus Q. That's it. Yes. Third question. If the resultant of the number of force acting on a body is 0, then the body will be in equilibrium. If the resultant of number of force acting on the body is 0, then the body will be in equilibrium. Yes, true. Fourth one, the two opposite and equal turning effect produced by the force on the body on which it acts is, listen, two opposite or equal turning effect. And the turning effect produced by the moment, two opposite means two opposite, and it attacks produce the force which acts is called, it is I would say distance. It should be distance should be there. It is couple. Moment is a single turning effect. It is rotational effect only. See one. There will be no rotational effect in two opposite and same forces. Two opposite and equal turning effect means two opposite and equal moment. It can also called as moment. This is couple. That's it. Fifth question: the algebraic sum of their moments at any point equal to the moment of the resultant force about same point is law of transmutative flow force, Saint-Venant principle, law of moments, and none of the above. Yeah, we know the Varigno's theorem or law of moments. Yeah. Resultant force of the above figure. Let's calculate the resultant force of the above figure. In force 2 and force 3, let's calculate one by one. Let's consider the horizontal force. Horizontal force is equal to summation of all horizontal force. This is H1 plus H2. Here force is 1 kilonewton. plus, which is moving on right side, plus 1 kilonewton, and plus 2 kilonewton, which is 3 kilonewton. Horizontal component is, horizontal force is, summation of horizontal force is 3 kilonewton, and summation of vertical force is, which is moving in 7 kilonewton is moving in downward direction, that means 9 minus 7, 3 kilonewton moving upward direction plus 3, that is 4 kilonewton. The resultant can be calculated as I explained in the in triangular law of forces. Resultant will be R equals to h square plus v square. H square plus v square is equal to R square. Resultant, or we can write it as R equals to square root of h square plus v square, where h is 3 square plus 4 square. 3 is 9 plus 4 16 equals to 25. Square root of 25 is 5. Resultant is R equals to 5 kilonewton. R equals to 5 kilonewton. R equals to 5 kilonewton. Let's see the options. Okay. Let's see the options. Here there is a 5 kilonewton. Our resultant we got is 5 kilonewton. R equals to 5 kilonewton. Resultant 5 kilonewton is that option answer 5 Newton. Okay, sorry, 5 Newton. It's not kilonewton, 5 Newton. Next, the principle of transmissibility of force states that when the force acts upon a body, its effect is same at every point on its line of action, different at different point of action, minimum or if it's act at the center of gravity of the body, maximum if it's act at the center of the gravity of the body. The first is the answer, but same at every point of its line of action. Line of action of all the force applied on the on line of action of one point, at every point of line of action which will have same effect. This is principle of transmissibility of force. Next answer is A. Next, a moment produce translatory motion, rotational motion, both above motion and none of the above. Rotational motion. It produces rotational motion. Thank you one and all. I like to acknowledge our team who has put much effort in preparing this e-content or this video session. I especially thank Tejamurthy sir, Dr. Chinagiri Gowda sir, and Dr. M.S. Chandrasekhar sir has taken much effort to bring this session, to make this session very successful. Thank you one and all.